All right, welcome back. I'm going to take you through some examples of computer output for significance tests and confidence intervals. Just to give you some guidance and some examples of this, there are more examples in your book because it does come out a lot. Because as you probably know, in real life, usually people don't sit around doing statistics with graphing calculators. In real life, we put data into computers, and the computers go ahead and calculate all kinds of things for us. Of course, we still need human beings because, as I've said before, any calculator or a computer can figure out a standard deviation. It's up to an actual human being to say, okay, well, what does that actually mean? What does that actually tell you? So here I have some output from two different computer programs. The one over here on the left is from a computer program called Fathom, and it's one you guys have seen me use before. It's usually the one that I use when I'm displaying things like grade distributions in class. The one on the right is from a computer program called Minitab, which again, you'll see a lot of examples of this in your textbook. It does show up on the AP exam quite often because it's a pretty popular program, especially on college campuses. And because AP Stat's supposed to be like an introductory stats course, they will incorporate things like, commonly used software at colleges. So both of these are regarding the same procedure. And if you look on here, it says the attribute is going to be BP change. So the background of this study is that they're looking to see what the blood pressure change was for two different treatment groups. And one of them was a group that was receiving calcium, and the other one was a placebo group. So over here on the Fathom output, you see the null hypothesis is that the population mean for blood pressure change for calcium is the same as the mean for placebo. The alternative hypothesis is going to be that the population mean for calcium is greater than that for placebo. So if I were to write this out, I would probably write something like mean for the calcium group minus mean for the placebo group is equal to 0, and my alternative would be mean for calcium minus mean for placebo is greater than 0. Here's some summary information. Now the first thing you see here is the sample size. One is 10 and one is 11, so obviously this cannot be paired data. If you have different samples that are different sizes, then it's usually pretty obvious, well, this must clearly be a two-sample procedure. If it was paired, it would of course have the same number in each group. Here we have the sample mean. So the sample mean for the calcium group was 5, and the sample standard deviation, and the standard error, which you guys know is going to be the sample standard deviation divided by the square root of the sample size, and that's where that comes from. For the placebo group, the mean was negative 0.27, the sample standard deviation, and the standard error also given. So the inferential statistics they've done comes down here on the bottom. The t-statistic they came up with was 1.604, and then they used degrees of freedom 15.5904 in order to get a p-value of about 0.064. Over here on the Minitab output, you have the exact same data. It's a slightly different output. So here we have samples, and it doesn't call them anything fancy. It's just group 1 and group 2. Here we have their sample sizes of 10 and 11. Here are the sample means, the sample standard deviations, and the standard error of the means. Here it shows you it's looking at the difference between means, and they've actually written out mu since it's harder to do Greek characters. And the estimate for the difference, that's going to be your point estimate, the difference between your sample means. So 5 minus negative 0.27, so there's a difference of 5.27. The alternative hypothesis here is not given in words, it's given in symbols. It says versus greater than. So you know your alternative hypothesis is going to be greater than. So the difference is going to be mu1 minus mu2 equals 0, so it says equals 0 here, versus greater than 0. The t-statistic it gives is 1.60, and the p-value is 0.065 using degrees of freedom 15. Now you can see that the number of digits each of these shows is going to be slightly different. They use slightly different degrees of freedom, so you're going to get slightly different results. But most computer programs will give you something that's pretty close. So I've asked you guys a question here. Just below, which is there evidence that the calcium group has a greater change in blood pressure than the placebo group? So normally you'd be doing a 4-step procedure for this, but on the AP exam they don't always ask you to do all 4 steps. In this case, they've figured out the hypotheses, and they've defined the parameters, and they've checked the conditions and done 2 sample t-tests, and they've actually they did their do step, and they came up with a p-value for both of these. All that's left to do is for you to conclude. So go ahead and pause the video and write out your conclusion. Now for this one, I did not actually give you an alpha and we don't have the stem of the problem, so I'm going to kind of go on the assumption that most of you guys chose to use a significance level of 0.05. So hopefully you got something like, since our p-value 0.065 or 0.064 is greater than our alpha of 0.05, we fail to reject the null hypothesis. Remember that your conclusion about whether to reject or fail to reject should be linked to the value of your p-value and an explicit comparison with some alpha. So, I mean, whether or not you use 5%, it should be using some reasonable value for alpha. Compare it, and then say, because of that, you reject or fail to reject. Your second sentence, that's where your context is coming from. So I put, we do not have convincing evidence that the calcium group has a greater change in blood pressure than the placebo group. So if you look here, you can see I got my context directly from the question, which is a great place to get it, because it asks, is there evidence that the calcium group has greater change in blood pressure than the placebo group? And I said, no, we do not have convincing evidence that the calcium group has greater change in blood pressure than the placebo group. Usually the actual question is a good place to get your context from. Below, I've given you an example of computer output for a confidence interval, and this is a confidence interval for proportions. And the background of this study is that there were some students from poor families, and they were put into two different treatment groups. One of them had preschool, and one of them did not have preschool. Then they did a longitudinal study. Later on, as adults, they counted how many required social services as adults. So here you have group 1, and this means there were 49 successes, and in this case, a success means that they required social services, out of a total sample size of 61. So their sample p, which is the p hat for group 1, was about 0.8. Below that we have our group 2, and we had 38 successes out of a sample size of 62, and our p hat for group 2 is about 0.61. So we're looking at the difference for P1 minus P2, where P1 is this group and P2 is the second group. The estimate for the difference, that's our point estimate. So that's going to be the difference between the two p hats. So this is p hat for group 1 minus p hat for group 2. And when we do this number plus or minus a margin of error, we get a 95% confidence interval, and our lower number is about 0.03, and our higher number is about 0.35-ish. So I've asked you to interpret this confidence interval and then explain what additional information it provides. So go ahead and pause and write out your conclusion. Hopefully it looks something like, we are 95% confident that the interval from, I used 3 decimal places here, 0.033 to 0.347, captures the true difference between the proportion of all students that attended preschool and students that did not attend preschool that required social services as adults. I am going to be the first person to admit a lot of times the context is kind of a pain. It can be long and wordy, but remember the conclusion is usually the last thing the grader sees. Make a good impression. Make sure you have really, really good context. The second thing that's on here is explain what additional information it provides, and like all confidence intervals, this confidence interval gives you an estimate for the true difference in proportions. In other words, it actually tells you about the magnitude of the difference, instead of just evaluating the claim that there is no difference or that there is a difference. So if we were to do a significance test using alpha of 5%, we would end up with statistically significant results because this confidence interval does not include the value 0. So, I mean, we'd be pretty confident in the assertion that there actually is a difference between these two groups. It does seem to make a difference whether or not, people have preschool as young children. Now, on the back here, I've given you a couple more examples, which I will talk through briefly. So this is actually 3 different examples, and it's one of the things that they do is that they will sometimes give you just enough information so that you have to kind of look carefully to see what's going on. So this first output is from Minitab, and it shows you a paired t-test, so obviously this is going to be a paired situation, for unscented minus scented. And the situation here is the response variable is how long it takes you to complete a maze when you're smelling like pleasant scents versus when you're not smelling any scents. So they actually gave you more information than you really need, because here you have, okay, for unscented, we had 21, data points, and this was our sample mean, standard deviation, standard error, the mean. and for the trials when it was scented, sample size, sample mean, sample standard deviation, and the standard error, and the differences. So we end up with 21 differences, and this is the mean of the differences. So calculated all the differences and then took the mean of the differences, the standard deviation of the differences, and the standard error, the mean for the differences. So they did a confidence interval for the mean difference, negative 4.76 to 6.67, and they did a t-test of the mean difference equals 0 versus the alternative hypothesis is greater than 0. T-statistic of 0.35, which is not very far away from 0, so as you might expect, the p-value is pretty large, 0.365. So really, you don't actually even need to know the information for this unscented and the scented. You just need to know the information for the differences, because we're doing a paired procedure here. It is possible that you might see computer output with more information than you actually need. If you were only given this part here and asked to figure some stuff out, you would have to figure out first, okay, should I be doing a two-sample or a paired procedure? And you might see something like that on an assessment sometime soon, just saying. The same data here is represented using DataDesk, which is another computer program, and it looks a little bit different here. So it's the mean of unscented minus scented is equal to 0, so that's the differences. So it's the mean of these differences, and it also tells you the direction of the difference, versus your alternative hypothesis, which is greater than 0. And then you can see more here about your degrees of freedom. And actually gives you a decision. Using alpha is 0.05. We'd failed to reject because our p-value is very, very large. And our last example that we have here is actually an Excel printout, which is not a current version of Excel. I actually haven't tried it on some of the more recent versions of Excel, so I'm not sure it looks exactly like this anymore. Excel, by the way, is not a very good program to do statistics with, so I would not recommend it. It's possible, not very likely, but it's possible you might see something like this. The only things I'm going to point out here is that it does give you your value for your t-statistic, which is the same as the examples above, and it gives you your p-value for one tail and for two tails. Because Excel does not know what your hypothesis is, it doesn't know if you want the area of one tail or two tails. So again, it's giving you more information than you probably are going to need, so you really need to be kind of discerning about what information you need before you start looking at all of these data. I've left you a couple of questions down here on the bottom, which I'm going to go ahead and let you guys do on your own because I think you can figure it out. And that's about all that I wanted to point out to you guys. I'm going to put some extra, since obviously our plans have kind of changed, some extra Chapter 10 multiple choice practice problems and a Chapter 10 Frappy. I'm probably also going to put up some student examples that you can look over. I mean, don't look at them until after you've done your own Frappy, and we can discuss this further in class. Think about what these student examples did well or did not do well. I can also go over the answers to the multiple choice in class as well. Come to class prepared for your quiz. I mean, if you have a few last questions before we start our quiz, that's one thing, but don't show up and expect me to go through an entire review, because that's kind of what you guys are expected to be doing today, and I mean possibly over this weekend, because I'm not sure exactly when you guys are going to be watching this. But take the time to get caught up on your homework if you haven't. Make sure you do your guided reading notes, because we are going to be starting Chapter 11, and we want to hit the ground running since I have no idea what the weather is going to be like in the next couple of weeks. And I guess that is it. I will be available by email, although I'm not checking it like every minute or anything, so there might be a bit of a delay in getting back to you guys. Other than that, let me know if you have any problems, and I will see you guys hopefully sometime soon.